On slide 20, I turn to step 3, namely finding deviations from the cycles. And the paper discusses 3 different alternatives that we're going to use 2 of. One is to add simply a dummy variable for certain days, or actually for certain time points, which is what we're going to do. And then you just check for significance of the effect. So that's step 3a, the step 3a run, where I use the loop plot to show the effect of that dummy variable. Second is a DSEM approach, Bayesian structural equation modeling with small variance priors. That one is discussed in the paper, but we will not talk about it here. And the third one I find very useful, and that is to use cross-classified RDSEM, residual DSEM, to find significant deviations from the cycles. And that's the step 3b run that I'm going to show you, and where you can save data that gives you information on which deviations are significant. So how is this done? Let's take a look at the step 3a run first. And on slide 21 you have the input. So the use variable list is expanded to having not only the 2 sine-cosine covariates, but also a Saturday dummy variable that we're creating here later on in define. And since it's cross-classified DSEM, we have 2 cluster variables, ID and time. T interval stays the same as before, and as before we put on the between level the x variables, the sine-cosine variables, and the Saturday dummy variable. So we put it on the between time level by putting time in parentheses here beforehand. I mean, it could also be between ID, so we have to make sure we're pointing in the right direction. Still a lag1 model, still x1 and x2 created this way, but now we add this specification that creates a dummy variable Saturday 1 or 0. So if you just think about it for a second, the study starts on a Tuesday, so Saturday is day 5. So before Saturday we then have 4 days with 8 time points, so 32 time points, and the end of Saturday is then 5 times 8, 40 time points. So Saturday ranges between time point 33 and time point 40. Here I actually cut off the first time point and the last time point of Saturday. Saturday again lasting from 33 to 40, but I'm saying greater than 33 and less than 40 because I didn't want to cover the whole day. I got a higher R-square for the Saturday edition if I limited myself to interior points, so to speak. Type equals cross-classified, base, B iterations, everything's the same. And the only thing that's different then is that on the between time level we have now added a Saturday predictor, PA on Saturday, that we give the label P3. On slide 22 then you have the loop plot, where the only new feature here is the Saturday designation of the Saturday effect. There the label P3 comes back in, and it says that we should add that in the interval of time points 34 and 39, including 34 and 39. So once again, cutting off the first time point 33 and cutting out the last time point 40 from the full Saturday range. And you can, if you have say a Sunday effect, you can just add that P4 times the Sunday time points that are relevant. So then you have a PA total, which is the PA cycles that we had before plus Saturday. And if you don't want it on the PA scale but on the B2A scale, on the factor score scale, you take the F cycles without the P0, adding Saturday. So let's take a look at Mplus output to see how that shows up. Let's look at the plot when we add this Saturday dummy variable. Let's work with the observed PA variable averaged over subjects, and we'll add timelines for clarity. So we have Tuesday, Wednesday, Thursday, Friday, Saturday. And what we do now is, as before, we insert a loop plot. And let's pick the PA cycles. And that's the part without the dummy variable. And we see then that on Saturday, the cycles underestimate the average positive affect development. And that then says that these adolescents are more excited on Saturdays than predicted by the cycle's behavior. You have other deviations too, but let's focus on Saturday. And we're going to take a look at these points, time point 34 to time point 39. Now, if we change the loop plot a little bit, we can look at the total, PA total, which adds the Saturday dummy, and it looks like this. So now you have this increase up here, better matching the higher excitement on Saturday for these adolescents. On slide 23, I turn to the third alternative of the step 3 finding of significant deviations from the cycles. And we're going to use cross-classified RDSEM, residual DSEM. The point here is that the cycles are estimated on the within level instead of the between time level. Before we had the two cycles variables x1 and x2 up here, now we have them down here in the within part of the model. That's also where a two-level analysis puts them. Now, the advantage here then is that deviations from the cycles can be captured on the between time level, because we have these time-specific latent variables on the between time level. So let's look at how this is done. And let's take a look at the step 3b, I call it, that run. The input is like this. You have the same setup as in 3a to a large extent. The only thing that, or one of the important things that changes, is that the within specification is used for x1 and x2. So the sine cosine covariates are on the within level instead of the between time level. And therefore, you have the x1 and x2 on the within level here, whereas the between time level has only this PA component, which will show you deviations from the cycles. Now on slide 25 then, you have the same setup as before. We are not adding any dummy variable here for Saturday. Same setup as before earlier on in 2a. But what's new here is this. We save data here. We save factor scores, 200 of them, with thinning of 10, that is we skip every 10th, and we save that in a file, factor score cycles deviations.data. So we're going to take a look at that in the Mplus output and talk about how that creates a way to test for significant deviations based on the between time specific values. In the save data command of the 3B run, we saved a file, fscyclesdeviations.dat, and at the end of the output, you see the order and the format of the variables, the different columns of the data set saved, with a PA variable, the cosinor variables x1, x2, the original hours variable, and the new time variable. And what's highlighted here then is the B2A for PA. It's mean. You can also use the median. And then we also have the standard deviation down here. And what you can do then is to take this file into another software like Excel and calculate the ratio of the mean divided by the standard deviation to get an approximately normal z-score variable. So you can check if that ratio exceeds 1.96 in absolute value, and you see at which time point or which time points that happens. So that is a way to use 3B analysis to find significant deviations from the cycles. To summarize the step 3B run, let's go back to slide 23 and once again take a look at the model. So it is a cross-classified DSEM model where the cycles variables are on the within level. So that's the reason why it's called DSEM instead of DSEM. That is, the dynamic relationship is not between the YW variables, but between their residuals once we have taken out the effect of the cycles. So it is a cross-classified DSEM with cycles estimated on the within level instead of the between level. Now, to remind you further then where we are in the big context, if you look at slide 14, we talked about the different cosinor model versions in Mplus, and what we just did was a cross-classified DSEM cycles on within fixed cycles coefficients. So the 7-parameter run here, run 3B, which is equivalent to the cross-classified DSEM fixed cycles coefficient run 2A here in terms of model fit and parameter estimates, but it affords 3B affords the advantage of looking at significant deviations. But they're the same model, and you also notice that this cross-classified DSEM with fixed cycles coefficients has 7 parameters. That is, it's a little bit more general than the fixed cycles coefficient run within the 2-level DSEM, which has only 6 parameters. And the difference is that between time component that gets added with cross-classified. Sometimes you don't need that, and 2-level DSEM is just fine.